Hello students, this is Mr. McAllen again, and this is our third video on um, working with monomial functions. And what we're going to look at in this video is end behavior of monomial functions. Now, what I'm hoping that you get out of this lesson is no matter what polynomial um, polynomial function you look at, you can always figure out what the function is doing at its ends. So when I say at its ends, I mean what is it looking like when x is heading to positive infinity or x is heading to negative infinity as you head out this way. And it's very, very easy to do. No matter how many terms your polynomial has, the polynomial's end behavior is always dictated by the highest power term. It will always look like that term. So the way we can describe end behavior is by using an end behavior model. So any polynomial you have, if they say describe the end behavior using an end behavior model, you would just say that the end behavior model is, and you would say what the last term is. Of this function, it is x cubed. Now, any polynomial I give you, if I give you like negative x to the 7th plus 4x cubed minus 2x plus 1. If I gave you that to be g of x, the end behavior model would be negative x to the 7th. So if they ever ask you to describe this with a picture, we have these little icons, or they're iconic drawings that are for end behavior appearances. So for example, anything that is an even polynomial degree has this end behavior icon. If it's a negative x to the even power, it would just be flipped upside down. It would look like a parabola with little squiggles in the middle, turning down. And if it was an odd one, you would draw it. The icon would appear like this. And if it was negative and x to the odd, it would appear like this because of the flip over the x-axis. So if they ever ask you to draw an end behavior model, you know what the drawings should look like. If they ever ask you what the end behavior function model would be, you would just pick the highest degree term. And let's just demonstrate how this works with Desmos. And the last thing that we would ask you to do is maybe use limits to describe the end behavior. And that is really the most advanced thing that we could hope that you would be able to do after watching this video. So if we go to Desmos, let's put in that function we had. We'll have to look at it again. I think it was x to the third minus 4x squared, x to the third minus 4x squared. I think it was minus 5x minus 3. It really doesn't matter what I make the rest of the polynomial to be. Here's my crazy looking polynomial. Okay, so that's, of course, it's like this part right here is the squiggle part that you see on the end behavior model. But if I draw, and I'm going to zoom in just to on the x-axis. So if you don't know how to zoom in on Desmos, you just hit the wrench, and I'm going to go from negative 10 out to, I'll go to 10, so it appears, like it just has a nicer shape. I just like the way it appears this way. So now I'm going to put the end behavior model in, x cubed, and if you look at it, you can see, well, that's x cubed, but how does that represent the end behavior model of what's going on here with the black function? But the black function and the red function won't start looking like each other until we zoom out and we look at what's happening at the ends. So like, if I go over on this side and I zoom out, and if I keep going out towards the ends, you can see as I zoom out further and further, you can see that the black and the red function become the same. So as x gets really, really large and y gets really, really large, the end behaviors of the cubed function match the four-term monomial or polynomial function. And the same thing happens on the other end, on the left end. So you can see here that that the red and the black function become the same. Again, when you zoom in close, I have have to just get back to the middle of the function again. Let me just hit the home button. You see that they don't look like each other at all, because when you're up close and x is low in value, end behavior isn't really an issue. We don't see the ends, but as we get out towards the ends of the function, the highest polynomial dictates what's happening. So just to demonstrate my point, let's say that I get rid of that end and I get rid of this end. Okay, now what polynomial should this look like? This polynomial's end behavior should look like negative 4x squared. That would be the polynomial that dictates everything. Well, clearly it looks like a polynomial that's been turned upside down, or a squared function. So let me put in the matching end behavior. And there you can see, well, at first, clearly you could say, they don't match at all. But as I zoom out, they're going to get closer and closer to each other. So here I'll just zoom all the way out, and I wish I could just zoom right in on this part, but you can see how the lines are getting closer and closer to each other, and as I let x go towards infinity, you're going to see their values are almost identical. So hopefully this video has been a good demonstration of end behavior modeling. And the last thing we want to do is describe, I almost forgot, is describe this end behavior with limit statements. So using a limit statement, if I were to look at the function and use a limit to describe end behavior, I would say, looking at, let's say we're talking about negative x to the 7th. Negative x to the 7th would look like this function, and you would say as an end behavior model, using a limit statement, as x goes to infinity, the y value is heading to infinity. So the way you write that limit up is you'd say as limit as x goes to infinity, g of x is also going to head to infinity. And you say equals, you don't say, you don't give the arrow for that. And for the other end, you would have to consider x heading to negative infinity, and the y value is heading to negative infinity. So the way you describe that with a limit is you would say the limit as x heads to negative infinity, g of x is going to equal negative infinity. So these would be your two limit statements to describe the end behavior. Okay, I think I've exceeded my time that I wanted to spend on this, and I hope this video helps you understand what's going on with end behavior modeling, and I look forward to hearing your comments.